While Thunderbolt works fine as is on the Gigabyte Z390 Designaire, some clever folks at TonyMacX86.com have found a way to squeeze even greater functionality from it by reflashing the flash memory. Go to TonyMacX86.com and find the Golden Build Forum. Look at the first post of the Gigabyte Designaire Z390 thread. Scroll down and reveal the mini guides for flashing SPI ROM chips spoiler. Scroll to find the mini guide using the Raspberry Pi. On the page are a list of supplies you'll need and links to some software packages. Download Raspberry Pi OS and Balena Etcher. Put the SD card into your computer and use Balena Etcher to write the image to an SD card. At the end, it will be in the ext4 format and unrecognized in the Mac, so you can just pull it out without ejecting it. Get a small outline integrated circuit clip for an 8-pin package. I bought mine on eBay. In the package, you'll find the clip itself and an interface board. Pin 1 is your reference, and the colored wire indicates this. Match it to pin 1 on the interface board and plug the connector into the board. Next, get a pack of female-to-female jumper leads, sometimes referred to as DuPont wires. You'll need at least 7 of them, but I have 8 here. Connect them in order, starting from pin 1. Note that historically ICs were round, therefore pin 5 continues in a clockwise fashion from the bottom view. Check your work. Unfortunately, the pins of the Raspberry Pi are not labeled, so it may help to mark each pin of interest. The power pin is at the end, and the ground connection is near the 2 surface mount components. Skip 3 pins to mark the final 4. The original table has been modified both for clarity and to incorporate the supplemental procedure for reading and writing the WinBond flash memory chip. Start with pin 1 and work your way down. At the end, you'll have 7 connections. The supplemental procedure uses the computer's power supply standby voltage to power the 3.3 volt rail, rather than trying to power it from the output of the Pi. For the particular case I used, there isn't adequate rear access to the flash memory chip. With the board removed from the case, turn it over to reveal the bottom of the board. Take the clip and, noting pin 1, put it onto the chip, making sure that it completely covers the IC. Be careful not to knock any components off the board. You should have already activated Serial Peripheral Interface and rebooted your Raspberry Pi. While the official instructions tell you to try reading the flash memory before you connect the power supply to the motherboard, I found there is enough residual voltage to get 2 successful readings before it failed. There's no harm in connecting the power supply first, as long as you take at least 3 readings and compare the checksums of each. Plug in the 24-pin ATX connector to the motherboard and turn on the power supply. The LEDs will light up. In the terminal window, change directory to the one containing the modified firmware you downloaded and unzipped. Next, type sudo space flashrom space -p space linux_spi : dev equals forward slash DEV forward slash SPIDEV 0.0, comma, SPISPEED equals 2048 space dash R space, and choose a name for your file ending in .bin. Check your syntax for accuracy before hitting enter. Next, use the up arrow to call up the last command and increment your file name. Do this twice for 3 consecutive readings. Now type SHASUM space asterisk. Hit enter and it'll return a checksum for each file in the directory. Make sure each file you read has the same checksum. Finally, we get to write the chip. Take note of the file name you're going to write. Type sudo space flashrom space -p space linux underscore SPI:/dev equals /dev /SPIDEV 0.0, comma, SPI speed equals 1024, space, -w, space, and the name of the firmware file you want to write. Check it carefully before hitting enter. If it completes successfully, you will receive confirmation.